Collaborative robots operate in direct interaction with human workers. Thus, collisions between a machine operator and moving parts of the robot are no longer completely avoidable. Physically separating protective devices are not present, and according to the ISO standard 10218, the robots operate in force and power limiting mode. The CoHoMe project is about homogenization and comparison of contact force safety measurements used for validating power and force limiting robot applications. The CoHoMe team consists of the UNEM Research Robotics Evaluation Lab, which took the lead of the project, the Smart Mini Factory in Bolzano, and the Smart Factory Lab of the Technical University in Graz. The approach of CoHoMe is to execute a series of 3 interlaboratory comparison measurement rounds. The defined experiments serve as a basis for ensuring a high-quality standard in data acquisition as well as in the competence enhancement of verification engineers executing the contact force measurements. The first round of experiments, named ILC1, has the goal of validating the measurement device and the basic skill of the measurement engineer. Therefore, the experiment is partitioned into 3 main parts. First, ILC 1.1 evaluates the behavior of the force sensor at static loads caused by test voids. Second, the experiment ILC 1.2 is about verifying dynamic properties of the measurement equipment at transient impact of moving objects at the measurement device surface. Strictly speaking, ILC 1.1 and 1.2 validate whether the measurement uncertainty for the evaluated force loads is within a defined limit range. Finally, ILC 1.3 is a guided experiment of validating contact force values at a robotic application executing basic linear movements. For ILC 1, the contact situations were strictly defined by the experimental setup. ILC 2 has the goal of assessing hazardous situations by a structured common risk assessment approach. Therefore, UNEM Research provided a video of a pick-and-place application and a risk assessment document template. The assessment results of CNR and DTI, including dangerous movements and thus contact points selected for measurements, were compared by an online risk assessment review meeting. Last, the UNEM Research Robotics Evaluation Lab validated the developed COVR protocols from ILC 1 and 2 at 2 real-world applications. The Smart Factory in Bolzano provided a medium complexity assembling task using a Universal Robots UR3. Based on a provided video, we identified 12 hazardous contact situations and estimated the risk level. On 2 days in January, we did the measurements and created a confidential measurement protocol, including a conformity assessment of the force values against the specified limits in ISO TS 15066. A second round of a real-world experiment was done at the provided application of the TU Graz Smart Factory this May. They also provided a video of an assembly task where a collaborative FANUC CR4 robot assists the operator. Based on an executed risk assessment, we selected 9 contact situations for measurement. Unfortunately, we had some technical issues on site caused by the FANUC robot, so that we only evaluated 5 of the 9 contact situations. However, also in this ILC3B experiment, the evaluated force values and the conformity assessment were documented in a confidential measurement report. As a concluding remark, as a follow-up activity beyond COVR, we recommend some more rounds of comparison experiments, further increasing the insight into measurement and risk assessment processes. Finally, the CoHoMe project, and even more important, the definition of COVR protocols, is a further progress towards an ISO 17025 conform safety evaluation standard for robot labs in Europe.